Okay, so in this section, we are going to look at something called composite functions. And what we're going to do is take two functions and put them together in a certain way to form something called a composite function. So here's our definition. Given functions f of x and g of x, we can form a new function which has this notation that's not fog, that's not an O. That little symbol right there in the middle actually means f composed with g. So we're doing a composite function of f and g. And f composed with g means that we're going to stick the function g in to the x value of f. Now we'll do some examples so you can understand how this works. All right, so we have two functions. Our first function for f is 2x minus 3, and our second function g is x squared plus 3x minus 2. We want to find four different composite functions, and then once we're done, we'll find their domains. All right, so let's start with the first composite function we want to find. We want to find f composed with g. Okay, so here's what we're going to do. Whichever one is first in the notation, in this case f, we're going to go up to f, and we're going to put parentheses in for its x. So I'm going to do 2 times parentheses minus 3, kind of like when we were doing functional notation for f before. Now, the second one in the notation, g, is going to get dropped into these parentheses. So I'm going to take all of this and drop it in here. So I'll have x squared plus 3x minus 2 inside the parentheses. Now, all we have to do is clean this function up. So let's distribute this 2 through the parentheses. We'll have 2x squared. And then let's see, we'll have 6x and then minus 4. And then we still have the minus 3 that's on the outside of the parentheses. And let's add the minus 4 and the minus 3, and we'll be done with this function. All right, and that's it. Minus 4 minus 3 is minus 7. And then we're done. All right, now it says to find the domains. So actually, let's come back to the domains after we've done all of the composites. So we're going to do g composed with f now. And I want you to notice that we're going to see that order makes a difference. So f composed with g will be a different function than g composed with f. All right, so let's look at the order here. G comes first. So we want to put parentheses into all of the x's of g. So I'm going to put a parenthesis there and a parenthesis there. So I'll have parentheses squared plus 3 times parentheses minus 2. All right, now f is second in the notation, so we're going to drop f into both of these sets of parentheses. So we'll drop 2x minus 3 in here and 2x minus 3 in here. Okay, now we just want to clean this thing up. So let's just write out what 2x minus 3 squared means. It means we're going to multiply it twice by itself. We can go ahead and distribute the 3. So that'll be 6x minus 9. I'll still have minus 2. But now let's FOIL out our 2x minus 3's. 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. Minus 3 times 2x is minus 6x. And minus 3 times minus 3 is positive 9. And then we still have a plus 6x minus 9 minus 2. Now let's add like terms and we'll be done with this thing. So we still have 4x squared, but let's add all of our x's. We have a negative 6 and a negative 6x will be negative 12x. Plus this 6x over here will be negative 6x. So we got minus 6x. Oops, I thought I was out of the exponent. There we go. And then our 9 and our minus 9 will cancel, but we still have a minus 2. Okay, now notice that G composed with F certainly looks different than f composed with g. All right, so they're different functions, and so order really does make a difference as we do these. So let's go to f composed with f. F is the first one in the notation, so we are going to put parentheses into f. So I'll have 2 times parentheses minus 3. All right, now notice that f, though, is second in the notation. So I'm going to plop f into the parentheses. So I'm going to plop 2x minus 3 in here. And now, let me take out some space there. Let's just clean this up. So let's distribute the 2 through the parentheses. We'll have 4x minus 6. And then I still have the minus 3. And if we add like terms, that's 4x minus 9. And that thing is done. All right, now let's do the last one of these, g composed with g. Now let's notice g is first in the parentheses, so we are going to put parentheses into the x's in g. So we will have parentheses squared, and then we will have plus 3 times parentheses, and then the minus 2. All right, but g is also second in the notation, so we're going to plop all of g into those parentheses. So this is going to be rather ugly. We're going to have x squared plus 3x minus 2 in here. Oops, minus 2. And I'll take out a little bit of the space there. And then let's plop that same thing into these parentheses as well. So we'll have x squared plus 3x minus 2. And again, I'll just get rid of some of that extra space. Now we got to clean this ugly thing up. And the hard part here is that we need to multiply out this squared quantity. So we have to multiply x squared plus 3x minus 2 by itself, x squared plus 3x minus 2. And that's not going to be pretty. We can go ahead and distribute our 3, though, so we'll have 3x squared, 9x, and negative 6, and we still have the minus 2. Now, let's deal with that ugly multiplication. Now, what we're going to do is just do it systematically. So what I'm going to do first is take that first term, x squared, and multiply it times everything in the second parenthesis. And then I'll take the second term, 3x, and multiply it times everything in the parenthesis. And then I'll take minus 2 and multiply it times everything in the parenthesis, and then we'll be done. All right, so let's start with x squared times everything over here. So we'll have x squared times x squared. That'll be x to the 4th. And now let's take x squared times the 3x. That will be 3x to the 3rd. All right, and then lastly, let's take x squared times negative 2. That will be negative 2x squared. Now I've multiplied the x squared times everything in that second parenthesis. Now let's take the 3x and multiply times everything in the second parenthesis. So 3x times x squared will be 3x cubed. All right, and then 3x times 3x will be 9x squared. And then 3x times minus 2 will be minus 6x. That's the 3x times everything. Now we need to take our minus 2 times everything over here. So minus 2 times x squared will be minus 2x squared. And then minus 2 times the 3x will be minus 6x. And then minus 2 times minus 2 will be plus 4. And then I'll just rewrite the rest of it. We'll add like terms here in a minute. Okay, so adding like terms, we still have an x to the 4th. All right. right, then let's see. 3x cubed and 3x cubed are like terms, so that's going to give us 6x cubed. And then let's add our x squares. Let's see, we have a negative 2x squared and a 9x squared is 7x squared. Minus 2x squared is 5x squared. Plus the 3x squared is 8x squared. All right. So let's see, that's all of our x squared. So let's see about our x's. We now have negative 6x, and negative 6x is negative 12x. Plus this 9x is negative 3x. All right, and now let's just add all of our constants. We have a plus 4 and a negative 6, that's negative 2. Minus 2 gives us minus 4. And that ugly thing is our g composed with g. All right, now let's find their domains, and then I'll do a second video for our second example of these. To find the domains of these, we need to find the domain of the second function in the notation. So I'm going to write that out. Now let me move this down so you can see it. To find the domain of a composite, find the domain of the second function in the notation, then find the domain of the final answer. Okay, now this kind of goes back to the domain problems we were doing earlier. All right, so let's look at our first one, f composed with g. G is the second one in the notation. G is a polynomial. And remember, the domains of polynomials were all real numbers. So really, G gives us no restrictions on our domain. It's all real numbers. If we look at our final answer, it too is a polynomial. So our domain remains all real numbers. Or you might remember that we could put that in interval notation as negative infinity to positive infinity. All right, so let's do G composed with F. So this time we look at F. F is also a polynomial, so its domain is all real numbers. If we look at the final answer, it too is a polynomial, so its domain is all real numbers. So this has domain all real numbers. All right, we can kind of guess that that's going to occur for the next two because we started with two polynomials. When we put them together, we have polynomials. But let's just go through the process. First one in the notation is f. F is a polynomial, so its domain is all real numbers. Our final answer is also a polynomial, so domain is still all real numbers. And then our last one, G, is the second one in the notation. I'm sorry, I think I accidentally said first one in the notation back here. G is the second one. We want to look at the second one in the notation. And if we look at that, G is again a polynomial. It has all real numbers for its domain. Our final answer, ugly as it is just a big old polynomial. It too has domain all real numbers. So this is, again, all real numbers. And pretty much we're going to see when we do a composite and we put together two polynomials, our domain is going to end up being all real numbers. But we'll see an example in a moment where we don't have two polynomials.